to all joining us today. My name is Adele Kroeg and I am from Food Focus. I want to thank the Dairy Standards Agency for sponsoring this webinar. It's been such a pleasure this year working with Jacqueline and her team on all the different topics and all the different webinars that they've hosted this year. I can't actually imagine that it's the last one for the year. But I do know that the Dairy Standard Agency have definitely served the industry well in terms of providing them with information on making sure that that we can improve the quality of milk and all other dairy products within the industry and for our consumers. And as I said before, that one of the projects of the DSA is information and education. And I think you all will agree that these webinars that they've hosted this year definitely prove that they are doing that to their utmost best. So today we've got a very interesting topic, and our topic today is pasteurization to the next level. The presentation will touch on the basic principles, but it will also focus on the down and upstream equipment and requirements to guarantee a safe and high quality product. The presentation will highlight pasteurization and will take it to the next level, meaning increasing the shelf life. To present this very interesting topic, we've got two gentlemen that are sitting ready to present, and I'm quickly just going to introduce both of them and then we will hand over to them to present. So firstly, we've got Riaan Botha. Riaan was born in Johannesburg in 1988, and after graduating in 2010 with a degree in polymer science, he persuaded a career in the packaging industry. And after 3 years in the packing industry, he moved to Luxembourg in Europe to take on business development for the role for Southern and Eastern Africa within the food processing industry. In 2016, Riaan joined, and I asked them before, and they said in South Africa, people refer to them as GEA Africa, and in Europe, some people say GEA. He became a sales engineer for Southern and Eastern Africa to develop the dairy and beverage processing industry with the use of separation and homogenization technology. During the 7 years with GEA, Riaan also held numerous positions within this environment, and he currently heads the separation and homogenization business for Southern and Eastern Africa. And before I'm going to hand over to him, I'm just going to introduce Jan as well. Jan Bank was born in the Netherlands in the 1970s, and after earning a mechanical degree, he started his career as a mechanical engineer, and he specialized in spray dryers. In this function, he worked for various projects in China, New Zealand, Brazil, South Africa, Philippines, and in Europe as well. In 2012, Jan joined GEA Mechanical Equipment, and in this function, he is responsible for the dairy and the beverage market in South Africa. And Jan is also currently staying in South Africa, and he's been living there for the past 12 years. So as you can see, we've got two gentlemen that's been with GEA for quite a while, and we are really looking forward to their presentation. So I'm now going to hand over.
Okay, so yeah, excuses for all the troubles. We're going through load shedding. Yeah, the connectivity is not that great. We're dealing with a firewall. I was dressed up really nicely for this presentation. The cameras are off, but I hope everybody can hear me. So quickly, we go to our company presentation. We are a public company, so all the figures, everything what I will show you can be found on internet, where we quarterly publish all our results as the company. So there are no secrets there. We can share this presentation in a later stage as well. Nevertheless, if you got any questions or in a later stage, please contact me or Riaan. You will find it on the second presentation. documentation, our contact rates. We therefore you if you want to speak with us. So quickly go to our company introduction. We a German-based company, and we focus on engineering. And let's say engineering for a better world. That is our slogan. So if you look at the company introduction, you see nice figures, what we all do, with an order intake, a revenue, how many employees we got worldwide, around 18,000, basically in 70 different countries in the world. But again, this can be all found on internet. We're not only focusing on dairy. I'm focusing mainly on dairy. My colleague Rian is focusing on dairy, beverage, environment, and so on. So you see, we presented in a lot of different industries. Definitely heating and refrigeration is one of our big pillars and really important. Because heating, we will talk about it, but also refrigeration is as important as heating. And without the proper cooling in place, you will still achieve nothing, especially if we're talking about fresh milk. So we see the different pillars in our organization, where we've got separation and flow technologies, where that is Rian's baby. Liquid and powder technologies, I'm responsible there. Then we also got the food and healthcare technologies, farm technologies, and again, heating and refrigeration. So this is how our country is set up. Quickly go to the different ones. So milk in production and for processing. Rian will tell more about this one now.
Yeah, so this is one of the divisions within GEA. It's separation and flow technologies, and within this division, there's 3 different components. So we've got separators, we have homogenizers, and we have valves and pumps. And on a global footprint for GEA, this is one of the largest divisions, where the manufacturing facilities are sitting in Germany and Ulder. So that's just the basis of separation and flow technologies. And we'll go a little bit deeper into the technology once we discuss pasteurization.
Yeah. So then we've got about production and processing. What we already said. We got also our farm technology colleagues, because that is what's all about farming. They do the milking robots and so on. So definitely that goes hand in hand with a lot of projects, where we sometimes do projects in one shot, where on the other side we got the farm, on the other side we got the process plant. Again, this can be found also on internet contact if you want to know more about robot milking machines and so on, rotary palas. Then my division, the milk production processing. So we call it liquid and powder. So on the right side, you see a nice spray dryer, quite a big one, probably somewhere in New Zealand. So this is my baby, where I'm responsible for the liquids and for the powder division within GEA. So more nice pictures. We go quickly through this because we still have to talk about pasteurization in general. So our country organization in the Sub-Saharan, where we both traveling to different countries, myself and Rian. So you will see worldwide, we almost everywhere in every continent, almost in every country, especially for the continent Africa, where you see the Southern Africa is controlled by GEA, where we've got different options agents in the Sub-Saharan. So if you look at it in South Africa, for example, we got 270 employees and 220 service technicians on the road every day. We got an office in Nigeria, Kenya, Angola, Namibia, Tanzania, Zimbabwe. You will see the amount of people where we, in some countries, are quite strongly. Some countries we don't have really much installed base, but definitely you see in Eastern Africa we quite present as well. Like again, also interesting to see, we can do basically everything on process sides, but every product you will find in the supermarket we can process for you, with the exception of cheese. Especially if it comes to hard cheeses, we don't have all the equipment, but besides for ice cream, yogurts, powders, and normal milk processing, fresh or UHT, ESL, we got all the processing equipment in place. Some more nice pictures. Rian will talk about the separators and homogenizers later on. This is what we do. We do it as one project is a brownfield project, greenfield project, where we got the milk reception, we got the process units, automatization, filling lines, and so on. Some more nice pictures, but I think we slowly will focusing on our next presentation. Finally, we come to the main topic, milk pasteurization, and we called it also increasing the shelf life, because we definitely see the most of our customers are interested in how can I basically increase my shelf life, how bigger the shelf life, how longer the shelf life, the better it is. Especially in Eastern Africa, where we have many battles, many challenges, but we actually achieved to have a really good shelf life there as well, even with the raw milk quality over there. So just an idea about milk production in South Africa. You see pasteurization, UHT, yogurt, and flavored milk. You see how it is basically set up of all the volumes. The nice thing is, if we're talking about UHT, yogurt, or flavored milk or cream, the first process step is still pasteurization, traditionally wise. UHT, we probably can do it different as well, but traditionally wise, first you do pasteurization, and after that, the next process step is UHT, it is a yogurt or it is a cream. Also, we got concentrated milks in South Africa, where we see cheese, got a big portion, butter, and your powders, like the skim milk powder, full milk powder. But again, to have a skim milk powder, you first need pasteurization. That is the first process step. Obviously, some countries where we export to, as we can see on the right side, just an idea. The gross value of milk production is 16 billion South African rands. That was achieved in 2019. The gross value of export is 3 billion South African rand, also in 2019. In 2019, roughly about 3.5 million tons of raw milk were processed at various dairy processors in South Africa. So now we're coming to pasteurization. History, probably everybody knows that Louis Pasteur is the founder of pasteurization, where we did a lot of basically research and a lot of discovery, especially if it comes to heating in a certain time. Especially the heating temperatures and the time is really important. You will find it in the next slides as well. Probably Louis Pasteur was also quite interested in wine, because he did some research there as well, at least to prevent decomposition of the wine in enclosed bottles. The next one is why pasteurization. In the past, raw milk could be bought at the farm or at the processor, so processing was not so much in place because it is raw milk. But we saw over the years that by regulation in the most of the countries, you have to pasteurize your milk. It's not allowed to sell raw milk anymore. We see in some African countries, you still, and in America as well, you can still buy raw milk at the farm. I really won't advise it, because you see some really ugly diseases there as well, which you definitely don't want to deal with an E. coli, salmonella, that are definitely, let's say, the disease is what you want to get out of your milk. And with pasteurization, you will achieve that. The good thing is pasteurization does not reduce the milk nutritional value. Although, to be honest, it has an effect on vitamin B12 and E, but it is really limited. And on the other hand, the eating will increase vitamin A. But all the pros and cons together, definitely pasteurization is a must. So the milk heating process, we will get in more details there as well. There are basically two ways to get your pasteurization in place, by batch or continuously. Batch we still see, that's really for smaller processors, or where there is a farm and they do some batch processing as heating. It's not really that accurate, not really that clean as well. It's more or less always an open system. It's not really great. So we actually provide a continuous process, and that will be achieved by a plate heat exchanger of the most of the times. You can do it by tubes as well, but probably 95% of the time it is done by plate heat exchangers. So your plate heat exchanger is a really important piece of equipment in the process. Like again, in heating process, the effects of pasteurization is actually really focusing on killing your spores, enzymes, so on, to get it out of it in a certain way that your milk is not destroyed. So we definitely achieve with the right equipment, with the accurate equipment, that you provide the cooking flavor. If your temperatures and time are a little bit off, because you are decided to go for cheaper equipment, it will have an effect on your quality of your milk. The cooking flavor will not happen if you got the right equipment in place. But if your temperature are too high, your proteins are really sensitive and they will probably burn. Everybody at home probably experiences it. You put a pan on your stove, put some milk in to heat it up. After a while, it goes wrong. You see that if you empty your milk, on the bottom you see a brown layer is really stick to the bottom of your pan, really difficult to clean. Those are burnt proteins, and that has an effect on your milk quality and taste. So on the diagram on the left-hand side, it is in German. I will show you now in the next slide the English version. But you see different blocks in green, like short-term heating, high temperature. On the top one is long-term heating. We don't see that in use anymore in the industry, because your holding time is 30 minutes, what's really long and really not efficient energy-wise. So the processors are choosing for a slightly higher temperature between 72 and 75 degrees centigrade with a holding time, depending on the kind of product, between 15 and 30 seconds. So quite a shorter holding time. And the next slide I will explain. We got also UHT heating where the temperature are much higher, but a way shorter holding time, 2 to 4 seconds. And sterilization is a little bit a lower temperature, 121 degrees centigrade, but 3 minutes. So like I said, the next slide will explain if you see high heating, short time pasteurization, the green lines of killing of germs, spores killing, also the green line where destruction is beginning. If you see the blue block of high heating, for example, you see the temperature is set on the line and your holding time goes up. So if you've got short time pasteurization, for example, it's really like, again, the time is really short, but it just starts on the killing of the germs. You don't want to really unnecessarily really go over it, because then basically your milk will be not of that kind of quality. Yeah, the times are really set as in this diagram is really important, especially if we go to higher temperatures of ultra high heating, where we really play about 150 degrees centigrade. If that time is too long, you will destroy your milk completely. You cannot process or you cannot sell it anymore. Again, whenever the audience got questions, now or later on, please ask us. The process steps for fresh ESL and UHT are mainly 5 steps. So the first step is heating up to 55 degrees, and that is all have to do with your separator. Because in your separator, that also will pick up in temperature, and you want to protect your proteins. So that's the first step, is really important that it is set at 55 degrees for your skimming. Then you go to standardization. Your homogenizer is in place, and process step number 5 will show you the temperatures and the holding times for pasteurization, ESL, and UHT. Now again, we talked about cooling. Why 4 degrees centigrade? At that temperature, your total spores are actually sleeping. So nothing will happen with the quality of your milk if you keep it cool. Obviously, that is also limited. But if you keep it cool and you got the right pieces of equipment in, what Jan will explain, we see with fresh milk we can achieve a shelf life of 14 days, ESL probably about 30 days, and UHT a year, but we normally say 6 months. So cooling is important. Like I say, your spores are doubling if the temperature goes up to an ambient temperature. So the cold chain is really important. Like I say, the norm in South Africa on spores when it comes to the processor is around 20,000 to 100,000 bacterial spores per milliliter, and that is the total spores. Obviously, we got challenges in Eastern Africa where the spores are much higher. That comes because the average farmer got 2 or 3 cows, so it will be collected amongst a lot of farmers, and when it reaches the process plants in the boiling sun, your bacterial spores are grown. But again, Rian also will explain that we got the right equipment to overcome those challenges. So now we go to the pasteurization process, and from this slide, Rian will take over now, because we also gonna highlight now the separator and the homogenizer more and more. So in this place you see a skimmer, what we call a cream separator, where we'll take off the cream. But we've got also different separators where we can take out the bacterials, or we can have a clarifier where we got also some kinds of spores out. I think slowly Jan will take over for the next slide and explain what's process happening there and what we can do to increase the shelf life.
Thank you, Jan. That's correct. Yes. So this is just a really basic flow diagram of a pasteurizer where you have in the ideal world incoming raw milk of 4 degrees Celsius, and in the plate heat exchanger we preheat it up to 55 degrees. And the reason for preheating before separation is at 55 degrees, that is your ideal and optimum separation zone. That's where you get the best separation efficiency from your skimmed milk and your cream. So a separator is just a basic mechanical equipment machine that works on densities. So if you look at skimmed milk and the cream in the raw milk, of course there's a slight density difference between them. To give you an example, if you have raw milk, you put it in a glass and you leave it outside for an hour, you will see that the cream will start floating and your skimmed milk will settle. So basically a separator that just does that continuously at a high capacity. So we have capacities in our range from 1,000 liters up to 60,000 liters an hour separator. So that's the basics of it. So when your raw milk feeds into the separator, it skims all the cream from your skimmed milk. Then you have options after the separator: manual standardization or automated standardization. So what that basically means is that is once you have removed all the cream from your raw milk, now you have a stream of skimmed milk. You can then start injecting back into your mainstream the percentage of cream that you would desire. So if you are running no fat or low fat products or full cream products, you can decide the percentage of cream that you would like to feed back in. So once that process has happened, the excess cream goes into a buffer tank, and your standardized milk goes back to the pasteurization system, back to the plate heat exchanger. There we heat it up to between 72 and 75 degrees Celsius to do the pasteurization, and that's where Jan was saying that's the ideal optimum heating profile to start killing the germs and spores and so forth. The separator as well is a self-ejecting separator. So what that means is while it's separating the two liquid mediums, it can also catch solids and eject solids. By doing that, you can, there's your raw milk coming in, there can be sand particles, there can be blood particles, there can be air and so forth. So that can be removed as well mechanically with the separator. We'll go into the options in the separator a little bit later. But the basics of this is then it goes back into your plate heat exchanger with a profile of 72 to 75 degrees. And then it gets cooled down to 4 degrees, and then it's done with the standard pasteurization process. Okay, so this is just showing your manual standardization. That's where your cream gets pushed back into your main stream. Then we go into a homogenizer as well. So now the second step is now to add a homogenizer. So we've discussed a pasteurization system without a homogenizer. Now we will just discuss one with adding the homogenizer. So after you ejected back your cream into your skimmed milk, it goes back into a homogenizer. So what a homogenizer does is it takes two different density products and mechanically break down the fat globules in your cream and make a homogenized product. The reason why we're doing this is to also increase your shelf life. So when after homogenization and pasteurization, that means when you pour a glass of milk and put it on the table, of course, you will not see any separation immediately because you've broken down the fat globules similar to the size of your skimmed milk globules. So the separation doesn't happen automatically like before homogenization.
Yeah, thank you, Rian. So, like Rian already said, it's important to have those pieces of equipment in place as well. So we can do it in different options. We can do it on a skid or separate pieces of equipment. I'll quickly go to the other slides. What we also talked about, and we also can highlight it later also when people are interested in. So increasing the shelf life. I already mentioned, how can we achieve that? So we see in some Eastern countries, they really try to crank up actually the temperature. I think how higher the temperature, how more bacterial spores I kill, how longer my shelf life will be. That is actually not really the right way to do it, because again, you will impact your flavor of your milk and the browning of your milk. Really in the past, when UHT milk just came out, let's say 40, 60 years ago, a lot of people didn't like it. It had really that brown, that burnt, flavory taste. That is not happening now those days anymore with the right equipment, because the temperature profiles are set really nicely. Now, bacterial spores are unfortunately found into milk. There's nothing what we can do. But we got a bacterial moving separator, what will take out those spores. The efficiency of that machine is roughly about 98%. So 98% of your spores will we take out, and then it goes back into the process and it goes to your skimmer. Or you skim first, then you do your bacterial moving separator. There are different options to set it up. If that 98%, and it sounds really silly, but in some countries it's not enough, because your bacterial spores are literally uncountable. We're talking about millions of spores. Then we put a next separator in place where you got two bacterial removing separators. The first one takes out 98% of your bacterial spores, and the next one takes 98% of those spores out again. That is proven in some countries that your milk quality then is really suitable for processing. So we can do it. We got one of our customers in South Africa got it, what we call the Prolong system. So that is found in, I think, the Western Cape or the Eastern Cape. The Northern Cape. The Northern Cape, sorry for that. And he got two of those separators in place, but he really wants to achieve the best quality and the best shelf life for his milk. So we do it, especially in India, in East Africa. We got those systems in place as well. We actually sold quite some bacterial moving separators, because again, they're not in control of how the milk is collected, how the milk will arrive at the process plant. So the bacterial moving separator is definitely one. We got the standard option, like I already said. It's something what we definitely can share. Don't want to spend too much time. I want also to have some time for answering some questions. This is basically the same what Rian already answered. Definitely, we've got the option for partial homogenization or full homogenization. Rian also can tell more about that, or when customers are interested in the process, Rian can also explain this. So now it comes to pressures and so on. So why is it 140 bars? Why is it 180 bars? In some cases, 240 bars. You really see to break down your milk, your globals. So for a normal fresh milk, when you say you got the shelf life is about 14 days, that the pressure can be, let's say, 120, 140 bars, because your globals are not coming back together after 20 days or after 40 days. So normally your milk is already at that stage when it achieved the shelf life. You still achieve that your milk is still like the fat is not coming together. We're talking about UHT when the shelf life is much longer. We can achieve a year. We really go to a 240 bar pressure to bring even more those flat globals down, so that we achieve even after a year your milk is still in a perfect condition. We got some nice pieces of featuring equipment. Rian can tell a little bit more about the nanovalve technology.
Yes, thanks, Jan. Yeah, basically, so GA has got on our nano Swabi homogenizers, we've got a standard homogenizing two-stage system where we do actually homogenization at, say, for instance, in this case, at pasteurized milk, we run a 200 bar combined pressures, first and second stage. And then we've got a new technology, or I will say new, but the last 4 or 5 years, we brought in a new system, a nano valve technology, where basically it's got the same effect as the standard valve, but at lower pressures. So at a standard valve at 200 bar, we can achieve the same effectiveness on the product if we run the nano valve at 160 bar. So 40 bar sounds like, okay, that's not a big change, but when you look at your maintenance, when you look at your energy efficiency, that plays a big role, because then you don't need to do the service as much as you used to do on the standard valve. Also, that you need much less energy. What GA also as a value add is our homogenizing valves work with pneumatic pressure and not with oil. Okay, so when it comes to some contamination and so forth as well, that's also an advantage. So that's just the very basics of homogenizers and its valves. And if you require any additional information with regards to this, we can have a 2-hour discussion just on that.
Yeah. Now you understand that's spot on. I mean, we can talk about the whole day about the homogenizer and all the features. The same is for our separators. We can talk about separating and what it's all about. Definitely one of our features is we call also we got Pro Plus. The Pro Plus system in our separation, where we're unique, we're the only one who got that system. GA actually did a lot of research there and spent a lot of money there to get the system in place. That works now for the last 10 years, yeah. I think, something like that. So the Pro Plus system makes it happen that you have to inject, in the end of the day, your separator. Because your milk is coming in, you're separating your cream. Unfortunately, you also separate non-milk what has to be ejected. Normally not a good part. So the injection in a normal separator takes place every 20 minutes. So every 20 minutes, unfortunately, you will lose also some raw milk or processed milk, and that goes basically to the drain. Depending on kind of separator, you got an holding spot, and for a 10,000 liter separator, that holding spot is about, call it 14 till 18 liters. So every 20 minutes, you go to the drain 18 to 20 liters of fresh milk, which you cannot sell anymore. That is unfortunately for everybody the same process. Now with the Pro Plus system, we got a system in place that we keep all the good parts in, like the proteins and so on. But like Rian, we can talk the whole day about it. But the good thing is that your injection time is now 90 minutes in some cases. So instead of 20 minutes, you go to 90 minutes. So that means you're saving a lot of milk, water, and energy. Those and proteins, and those four combined, you will be amazed about the cost. You easily can run your maintenance on that cost saving of a normal dairy and average dairy industry. So maybe Rian can highlight a little bit about this Pro Plus system.
Yeah, so the Pro Plus is a very important let's say topic when it comes to separation. Like Jan was explaining, the standard ejection time for a standard separator at 10,000 liters is between 15 and 20 minutes. But with the prolonged system or the Pro Plus system, we can keep the solids in the holding space for much longer. So you concentrate the solids much more. So that means when you inject, it can be up to 90 minutes. So I've done a calculation recently, and by just saving on your product or milk losses, as well as energy and maintenance, because you don't need to open up the bowl frequently. So just by those three topics, milk losses, maintenance, and energy, you can save at a 10,000 liter an hour machine. If it runs 300 days a year, you can save between 800 and a million ZAR, just by having that specific system. So it's just an add-on on a new machine, but it's a must-add if you want to have a very efficient and lean process.
Yeah, thank you, Jan. So that's definitely one of the topics. Also, the separator which you see now is the normal separator which you see in every dairy. With the belt-driven machine, we still got the gearbox machines in place as well. Now those days, we got the direct drive machines. So there is no belt in place anymore. The motor is placed under the ball. The drive is directly to the ball. So normally with a gearbox machine, the efficiency drops down because you got your gearbox, you got your clutch. So that will take away 10% of the efficiency. So if you got a gearbox machine, it drops by 30% efficiency energy-wise. If you got the belt-driven machine, it drops roughly about 12%, 15% energy-wise, efficiency-wise. If you got your motor directly under your ball, you got basically an efficiency of 98%, 97%. That last 3% is just the friction of your ball. You unfortunately never can achieve a 100% efficiency. That would be great. But it also means, again, we can talk about separation, the homogenizers for probably the whole day. Might be an interesting topic for the next online meeting. So I'll go a little bit to the temperatures because we're running a little bit against time. But again, you can find us, me and Rian. We can answer every question now or in a later stage if the connection is not really that great. So the last pieces of we go through it. We will obviously share this as well. This presentation. You see a nice model there as a skid model with your separator on top of it, with your pasteurizer as one unit, can be placed in a container and shipped all over the world. Now capacity starting with 3,000 liters an hour up to probably 70,000 liters an hour. So there are no limits there. We also quite specialized in what we call the lower volumes, is 2,000, 3,000 liters an hour. Again, we will share this a little bit again about the temperature profiles, the capacity profiles, and so on. So again, we do the whole P&ID. So if we do the engineering for you, we can do it from scratch, everything. So we deliver the drawings, we do the installation and commissioning as one-stop shop. So regarding that, some nice pictures, another nice picture with a bacteria removing separator and a skimmer in place. Yeah. Also, you find out details here from myself and from Rian. So please, if you got any questions, mail, call us. We're there for you. Adele, we about to end our presentation. Are there any questions from the audience or any questions from your side?
Yes, Jan, Rian, thank you very much. Very technical presentation and very technical drawings, just showing how qualified you gentlemen are in terms of knowing and understanding how your equipment works. So I've got one question, and it is from Janusz, and he's asking, he says that he understands the standardization of the fat content, but he's asking, how do you standardize the protein content?
Yeah. Okay, this is an excellent question. I think Rian is really the right person to do. So, but I can also take it over. The question is, how do you standardize the proteins?
Yes, the protein content, correct.
Yeah. So, as Rian explained, if you've got a glass with milk, we're dealing with two phases. We're dealing with the light phase, and we're dealing with the heavy phase in milk. So light means fat. Fat will go up, and proteins and bacterials will go down. That is the natural separation of milk. So our machine is actually orientated on fat. That is a skimmer. So fat will orientate on the light phase, will take out that fat. But if we got the Pro Plus system, that system also orientates on the proteins. Now, proteins and bacterials are what we call, let's say, family of each other. Those two are laying so close to each other, although proteins are just a little bit lighter as bacterials. Our Pro Plus system makes it happen that they separate all those proteins out and keep the bad parts in. That is that Pro Plus system where we talked about. I think that might be a quite technical explanation, but again, please, if you want to find out more, we can give you a detailed presentation and go through that system, how you can regulate your proteins and your fat and so on, also on a standardization way. So unfortunately, we cannot standardize your proteins separately out. That is unfortunately not possible. So your proteins are standardized together with your fat. Also have to find that out from the specialist in Germany. If there are some developments in there, but so far I know and Rian know it's not a system like that where we can separate or standardize your proteins completely out. But again, we can speak with the German specialist, because we got just one guy who knows everything about proteins and bacterials. He's a professor regarding that. So we can also speak about that, but please contact us and we can go to a separate presentation, because that will take probably an hour to explain.
That's 100%. I'm sure of it in terms of the way that you've explained it. Should there be any further questions or if it's not clear, then I will make sure that Janusz, you get his details and then he can contact you further. We've got another question here. Can these machines be used for juice applications as well?
Yeah, absolutely. So we really highlighted milk pasteurization. On the other hand, we can do juice pasteurization as well. And also the homogenizer is obviously in place. There is no limits. If it is a clear juice, if it is a juice with fibers, we can do it. Normally, we don't do it to a plain pack, what we call, but when we got juice, when the fibers are bigger than a certain, how you call it? Microns. If they are above a certain microns, then we choose the tube heater. But definitely, we sold those. We got them in the country as well to have a juice production line. It can be any juice what you can find.
Okay.
I'll also just explain 1 minute. So you basically, Janus, so you've got different juices, right? So what we normally look at when we spec separator and homogenizer and the pasteurizer itself, we look at the center point viscosity of the product. We look at the fiber length, if any, and then we start, assessing what technology and equipment is required. If you have a fibrous product, for instance, you need tubes like Jan was explaining, but also then on the homogenizing side, you only need a single stage homogenization unit, because if you start breaking fibers, you break it once and it can't go back to each other. You can't reconnect like fats in milk. When you break a fat globule in milk, over time they can reconnect and grow in size, but fibers cannot. So that's just the basics, yeah. But please contact us if you need additional information on that.
Okay. Just then, sorry, clarity in terms of the explanation that you did in terms of the proteins. Janis just wants to know, is it not true that for the standardization of the proteins that you utilize membranes?
That can be done by membrane filtration, but that is really a completely different process.
Okay.
And really an expensive process, and it takes up a lot of your space in the factory as well. Definitely we do it also with membrane filtration. That can be done in different steps as a normal RO, microfiltration, and so on. So we also got departments who does filtration. Currently we do it to reduce actually your milk volume as a benefit of transporting your milk. So we definitely take it out, let's call it water.
Yes.
And that will be reduced by 30% of your milk. So you have to transport 30% less with the same effect as if you go into a spray dryer, for example, where you also have to take the water out. So currently we're doing it. So definitely there are different options there as well as it comes to filtration. But again, that will be almost a 2-hour, 3-hour
presentation. Okay, no, that's 100%. I'm sure of it. If he wants more clarity, he'll make contact with you because your information is on the screen, so he can reach out to you. Then I've got 3 more questions, and the first one is, should cream of 30% be homogenized, and what is the benefit of that?
I think that's just more the 30% cream homogenization probably Jan can answer why you still have to do that. So yes, it can be homogenized. So it depends on what you want to use the cream for, right? So the standard pasteurization process is when you skim your milk, right? Your separator works at a certain efficiency, and the excess cream, like I was explaining also earlier, it goes to a buffer tank. That buffer tank used to pasteurize. We also can sell cream pasteurizers after this process, right? Then you pasteurize your cream, and then in that process you can also homogenize it, depending on what you want to do for it with the actual cream. Are you going to make butter? Are you going to sell it into the bakery industry? Are you going to reuse it in yogurt applications? So that is also a very broad answer that we can give. It depends on what you want to do, what you want to use the cream for.
Yeah.
So in certain places you don't need to homogenize it, but it depends on what you want to do it and how you want to store it. Right?
Yes. Okay. Then someone picked up on one of your slides that you showed that the incoming milk is at 6 degrees, but you did mention it is 4, and I think local legislation also indicates that the milk must be at 4 degrees. Am I right?
Yeah, correct. I have to double check that slide. It might be a typo, but I'm not sure if it is a regulation. No, it's not. It is not really a regulation, but we advise to do so at 4 degrees. Some processors even do it at 3 degrees centigrade, just to achieve a better shelf life. We can also process it at 20 degrees centigrade, but it just affects your shelf life. So the 4 degrees or 6 degrees is not a regulation, but it's just to create a better shelf life.
Okay, 100%. Then I've got a very important question here that I really would like to ask is someone, I think you would pronounce his name as Bartholomew. Bartholomew is asking, he's saying that thank you very much for the presentation at first, but then he says, with the emergency of small scale processes, are you able to manufacture smaller machines, separators, homogenizers? And he says, can you get smaller than 3,000 liters per hour?
We got them, and what we call more the laboratorium equipment. So we got smaller homogenizers and separators in place as well, but we mainly sell this for testing of your milk in a laboratorium. On the other hand, with the prices now in place of raw milk, processed milk in the supermarkets, dairy processing is a volume game. You need volumes to break even or make money. Unless it is a really niche product, we see that sometimes as well, but it starts with 3,000 liters an hour, mainly, ideally 10,000 liters an hour.
So just to answer that question from the scaling point of view, so it is possible to have to build a pasteurizer that can do 1,000 liters of milk an hour. That would be the smallest, but like Jan was explaining, it's the cost for 1,000 liter pasteurizer and the cost for a 3,000 liter is exactly the same, because we say the range between 1,000 and 3,000. The only difference is you have the same separator, the same homogenizer, the only difference is the amount of plate packs you use in your pasteurizer for the capacity. So the smallest we can do is 1,000 liters, but the most effective in the industry to actually make a profit on your process and justifying the investment cost is calculated at 3,000. But I mean, any scenario is possible, right?
Absolutely, absolutely. Okay, and then it's the last question, and it's a technical question. How often should heat plate seals be replaced?
That is really the seals. Just seals in particular, or not just in general, the heat seal?
The heat.
I assume it's between the plate packs then.
Yeah, the question is just saying heat plate seals. So,
okay. Yeah,
that's the gaskets on the plate heater.
Yeah. So it really varies of your running times, obvious, how many operation running times you got. In general, on the plate packs, we advise twice a year to have a maintenance in place. And that is just to check the condition of your gaskets and so on. Depending on your running hours, I believe it is once a year, what I see.
Yeah, but it also depends. It also depends on what your process conditions are, depending on temperature profiles, right? So your gaskets are spec'd to actually handle a certain temperature. So if your gaskets are spec'd at 75 degrees on pasteurization and you use 90 degrees, for instance, of course your gaskets will deteriorate with temperature. So what we do normally is, in a preventative maintenance situation, we would have always gaskets in place, but normally we change them every 6,000 hours, and that's the ideal way so you don't get any leaks and that's where you get loss, right? On your plate pads. So yeah, it depends. There's a lot of answers for specific questions, and the best would be for the listeners to contact us directly with specific questions, so we can give you detail in your specific question. Yeah.
So definitely what we do if we're dealing with a new project and a customer got a certain request, want to produce a certain dairy product at a certain volume, we do the engineering. We know which kind of machines are in place, Rian separator, homogenizer, pasteurizer, and so on. We normally can give the maintenance cost in place as well. So the maintenance cost for the first year, second year, third year, and so on. So that is not a problem at all. If we know what kind of equipment is in place, we quite easily can contact our maintenance department. will give us the cost, what is in place for the future, and so on.
Jan, Rian, thank you so much for that very technical presentation and your advice and answering the questions. I'm sure of it, the delegates really appreciate that, and they've got your details. So I'm sure they will be able to reach out to you if they've got any further questions. So I'm going to say goodbye to you two on the phone, and on behalf of Dairy Standard Agency and Food Focus, thank you very much for the presentation, and we are looking forward to the PDF that you will send through to us that we can then make part of the recording. So I'm going to sign off on my cell phone to the two gentlemen, and just thank you very much for your time. We really, really appreciate it.
Thank you so much, and you're more than welcome.
Okay, then have a lovely day. Goodbye.
You too. Thank you.
To all you, thank you very much for your time. Thank you for signing in once again to the Dairy Standard Agency for sponsoring these webinars and hosting it with us. Like all the previous recordings, this one will also be available on our website on www.foodfocus.co.za under resources. All the webinars that we've hosted with the Dairy Standard Agency, you can go and have a listen to the recordings there. Please also note directly after the webinar closes down, there's a short survey. We please ask you to answer the survey to ensure that we keep on bringing topics to you that will assist and help you within the industry. We've loved working with Jacqueline and her team. We're really hoping and looking forward to next year. And yeah, it's so funny to say and actually scary to say, but to all the attendees, we've had many attendees that signed in on all 10 of the webinars, and we really want to say thank you to you for your support, and we hope that you will keep on supporting us in the new year. And yeah, scary to say something like, may you all have a very blessed last few weeks prior to Christmas. And if you go into the festive season, or if you're going on holiday, please be safe, look after yourself, and may you have a very blessed festive season. And we are looking forward to seeing you next year on the platform again, and bring you more interesting topics and information. Have a blessed day, and until next time, thank you so much. Goodbye.